Good morning. Everybody is doing well. We'll give everybody, we've still got a few more people to log in. We'll give everybody a chance to do that. Is there anybody that has not had a chance to print out the sheet that I sent? Has everybody seen the email that I sent with some notes? So everybody has been able to print it out? Get Sadie in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Got 3 more to join. Give it just a few more minutes and let everybody get logged in. Melly. All right, well, I don't see anybody else logging in. So really quick, go ahead and I want to do a quick check. Everybody turn your screens on so I can see your lovely faces for a moment, so I can make sure everybody's there, so I can make sure everybody is good, so you can kind of wave at me if there's something that you need or something that you don't have. So just you can give me a nod when I make sure, when I ask you about the sheets that I've given you. Okay, so I sent an email yesterday with our lesson notes. And so I just want to make sure that, you know, just with a nod that you can tell me that you got the notes. Everybody nodding? Anybody shaking their head? No. Okay, awesome. So everybody got the notes. So has everybody had a chance to print them out? Is there anybody that needs a minute to print them out? Or is everybody good to go? Okay, awesome. What I wanted to make sure, what I'm going to start doing is we're going to be having our note sheets that we're going to be kind of working through. I'm hoping that number one, for those of you that have had me before, y'all know that we usually took pretty heavy notes in class. And so that's one of the things that I have hated about the way things have transitioned this year is we haven't been taking the same consistent notes. I tried to add the note taking into the homework part of it, so that way you're still taking some notes, but then as I kind of reflected over it during the break, trying to figure out what can we do to make things better this year. One of the things that I'm going to try is doing these notes, and y'all can go ahead and y'all can turn your cameras off now. I just wanted to make sure to see everybody, make sure everybody was paying attention to what I'm saying. You can, if you want to turn your camera off, that's fine. But the main thing is for you to have a consistent set of notes that number one will help you not only understand the material, but number two will everybody has the same notes to study from for a test. Okay, so it's kind of a combination thing that will help as far as understanding and learning the material, but then also you have a set of notes to study from when you're preparing for a test. Also, it will eliminate you having to write lesson notes in your homework. Okay, so that's the purpose of me kind of shifting to this, is hopefully it'll make things a little bit easier on you because you're not having to write lesson notes in your homework. Plus you have something to study for a test. And so that's kind of the purpose in it. For right now, obviously it's a little more difficult because I'm having to mail them to you and or email them to you and you're having to print them out. Now, obviously week after next, that will not be an issue because I'll be able to go ahead and have the copies ready to hand you. My plan is to go ahead and have each section ready at a time. So it's not like each day you're getting a new sheet. I'm going to have a stapled pack of papers for you to have that when we're doing that entire unit, you've got it all together. Then at the end of the unit, when we have the test, you will turn that packet in. Okay, so this will be for a grade. So make sure that as we're going through and we're filling in answers on our packets, that you're putting your answers in your packet, because number one, it also has your homework assignment on it. So it's going to have the notes for the day. There may be some things that we add to it, that as we fill in blanks, we may find that we want to jot down a note, or it could be that as I was typing them, I left something out and I go, hey, let's add this in there. It'll be a good, consistent way to be able to keep your stuff together. So we'll go through them in class. And then also at the end of each section, it has a homework assignment. Okay. Now I have put on there which lesson it correlates with in the book. You'll also notice that usually I have gone ahead and transferred the classwork problems from the textbook. I have put those on the packet. So you do not have to write the classwork problems in the book. You'll actually just write them in the packet. Okay. So as you're following along during class, when we're working these practice problems, you're working it in the packet and that gets turned in with your test. Okay. So we'll kind of go through them. We'll kind of talk through it all and everything. But the first thing I want to do before we shift to working in the packet is I do want to look at our homework assignments that we had. I know I didn't send those homework things for you. I wanted to go ahead and go over them in class. So the first thing we had, real quick, I'm going to share my screen so we can look at what we had. Let's see, share my screen. Pull this up so I can make sure if anybody else tries to join, I can see who all, anybody needs to be admitted. Give me just a sec. Let's see who also, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Good. So we've got everybody. I know Mark was going to be out today. So now, okay. All right, so on Monday, we were talking about our inequalities. We talked about graphing inequalities, and this was the little note that I sent you guys that on separate sheets of paper, we were doing the solving inequalities one worksheet from our packet, our inequalities packet, and then inequalities 3, we were graphing those 3. So real quick, let me make myself a note so I don't have to keep going back and forth. Hold on just a second. So we have inequalities number 1, 3, 6, 9, and 12. Inequalities number 3, 1, 2, 4, and 5. And then we had worksheet 25. We were graphing the left column. So we're going to go through all of these real quick. Let me go back to my packet. Okay, so inequalities 1. Oh, that's not where I want to be. There we go. Okay. So let's go ahead and check our homework for this one. So we were graphing these. So divide by -5, divide by -5. So here, when I divide by a negative, I've got to flip that sign. So you should have had x is less than negative, and let's see, 80 divided by 5 is going to be 16. So x is less than -16. So when I graph that, I would have 0, a positive 16 here, a negative 16 here. I know that it's going to be an open circle because it is just less than, open circle at 16. I look at the direction my arrow is facing and I would shade to the left. Any questions on that one? Look at it. Did you remember to flip your sign? Okay, because flipping the sign makes all the difference. If you didn't flip your sign, then your arrow is going in the wrong direction. Your shading is going in the wrong direction. All right, so for number 6, I would subtract 130 from each side. And x is less than or equal to 400. So again, draw my graph. My zero's in the middle. I'll put 400 over here, negative 400 over here. Now, x is less than or equal to 400. So I know I have a closed circle at 400. And I see that my arrow is pointing to the left, so I'm going to shade everything to the left. Questions on that one?
Doesn't negative 400 need a closed circle too?
Say that again.
Does negative 400 need a closed circle too?
No, I'm only, because I have x is less than or equal to 400. The only place I put my circle is going to be at 400.
I'm looking at the packet now, and I'm trying to find the page you have because I don't have it in my. I've looked on every page, and none of those questions line up with the pages I have.
Okay, so it was inequalities number 1, and this was the packet you were supposed to have turned in to me already.
I did, but I already. I'm looking at my inequalities number 1. Oh, wait, I have absolute value inequalities. I don't have solving inequalities number 1.
Okay, we'll check through because that was one of the
I have solving inequalities number 4, but not number 1.
Okay, so the packet that I emailed you was solving inequalities number 1, solving inequalities number 3, solving absolute value inequalities 1, absolute value inequalities 3, and solving inequalities 4. So there were 5 pages that you should have.
Okay.
So if you don't have it, I can re-email it to you. Let me make a note, because that means one of your pages is missing from your original inequalities packet.
Thank you. I have I have a lot of notes, but I don't have that.
Okay, so you'll just need to print out whatever sheet you're missing from that. Okay. All right, now we're going to go to number 9. Okay, so I have 25 plus 6x is less than 300. So the first thing I need to do is subtract 25 from each side. So 6x is less than, and then 300 minus 25 is going to give me 275. And so now I need to divide by 6, divide by 6, and x is less than, and on this one, I ended up with a decimal, and I have 48.83, and my 3 is repeating. So again, on my number line, I'm just going to go ahead and have 0 here and have 45.83 repeating, negative 45.83 repeating. I'm going to have an open circle, and then my arrow points to the left. Any questions on that one? All righty, number 12, subtract 25 from each side. I have negative 8x is less than or equal to 200. Excuse me. Divide by negative 8, divide by negative 8. Dividing by a negative, I need to flip my sign. X is greater than or equal to negative 25. Look and check, did you flip your sign? I have positive 25, negative 25. I'm going to have a closed circle at negative 25. My arrow goes to the right, so I shade to the right. Okay, so that was our first part of our homework. The next one was inequalities number 3. So I'm going to go to that one. And we did 1, 2, 4, and 5 on this one. Okay, so, excuse me. Was it inequalities number 3 or absolute value inequalities? It was absolute value inequalities, right?
Yes, ma'am.
Page 3. Sorry. Yep, there it is. There it is. Okay, so remember, we have different rules for doing our greater than and less than when we have absolute value inequalities. So what I'm going to do is I'm going to do them, I'm going to do numbers 1 and 4 first, and then we'll go to 2 and 5, okay, since we're dealing with them doing different methods. So I'm going to go ahead and start with number 1. So number 1, we're dealing with our less than, so this is where we have a consistent line where we have and. Everything is this happens and this happens, whereas our greater than is when we have or. So starting with the first one, I know that I'm going to have negative 21 is less than 2x plus 5, which is less than 21. Therefore, negative 21 is less than 2x plus 5. And 2x plus 5 is less than 21. So I'm going to subtract 5, and negative 26 is less than 2x. Divide by 2, divide by 2. So negative 13 is less than x. Over here, I subtract 5 and subtract 5. 2x is less than 16. Divide by 2, divide by 2. X is less than 8. So I have negative 13 is less than x, which is less than 8 is my solution, okay? So to graph that, I have my number line. And what I'm going to do is I'm just going to number, I've got 0. I'm going to put my positive 8 here. I'm going to come over here and put negative 13. Now remember, I only have less than signs. It's not less than or equal to. So each of these will have open circles. And then all of my answer solutions are going to fall between negative 13 and 8. So I have 2 endpoints or 2 open circles, and then I'm shading between those 2 because the way my answer is written is that x is going to be between negative 13 and 8. So that's what that graph shows me. So now number 4, same thing. I start with my negative 50 is less than 15 plus 5x, which is less than positive 50. Break it up into 2 statements so I can solve each. All right, that plus sign looks like an X. Let me fix that. All right, so on the left-hand side, I'm going to start by subtracting 15, subtract 15, and negative 50 minus 15 is going to be negative 65. Negative 65 is less than 5x. Now, one of the things I want you to notice here, oh, and let's see, I want to make sure to put up my list in case anybody gets kicked out and I need to put you back in the group. Okay, sorry. So notice here, I have negative 65 is less than 5x, okay? What am I going to divide by? What am I going to divide by to solve for x?
5.
5. Is it positive or negative?
Positive.
Positive. Okay, so I think that when I was looking at some of the sheets, some of you said, hey, I've got a negative number here and I'm dividing. I am dividing negative 65 by 5, but my 5 that I'm dividing by is positive. I do not flip my sign here. I only flip my sign when I divide by a negative number. Okay, so look at your work. Did you flip your sign here? If you did, let's go ahead and fix it. Okay, it should not be flipped because I'm not dividing by a negative number. All right, so negative 65 divided by a positive 5 is negative 13 is less than x. So now on the right-hand side, again, I subtract 15. Subtract 15. So 5x is going to be less than 35. Divide by 5, divide by 5, and x is less than 7. So now my combined solution is negative 13 is less than x, which is less than 7. So my number line, again, is going to be fairly similar to the first one. Actually, let me move this over just a tad. So I have 7 over here, negative 13 over here. Open circles again. Shade between the two because I know my solution will fall between negative 13 and positive 7. Any questions on that one? All right, shifting to our greater than symbols. So remember, greater than, this is where we have or, okay? So I'm going to have it set up to where when I set up my two equations, I'm having to flip my symbol, okay? So the first one I'm going to have is I'm going to go ahead and keep everything exactly like it is, but I'm going to drop the absolute value symbol. So I'm going to have 8x plus 8 is greater than 40. Or I'm going to have 8x plus 8. That stays the same, but now I flip my sign and I take the opposite of what was on the right-hand side. So those are my two statements. I'm going to subtract 8, subtract 8. 8x is greater than 32. Divide by 8, divide by 8. And 32 divided by 8 is 4. So x is greater than 4. Over here, I'm going to subtract 8, and 8x is going to be less than a negative 48. Divide by 8, divide by 8, and x is less than, excuse me, negative 6. So I know my solution is x is greater than 4, or x is less than negative 6. So I've got 0. I'm going to put my positive 4 over here. I'll put my negative 6 over here. I know that they're both open circles. I'm going to start with my 4. So I have an open circle at 4. And then I see that my arrow goes to the right. So I know that that x could be greater than 4. Or I know that x could be less than negative 6. So my open circle at 6 and my arrow is going this way. Any questions about that one? All righty, now let's look at number 5. Number 5, again, I just dropped my absolute value and I have x divided by 4 plus 2 is greater than or equal to 12. Or x divided by 4 plus 2 is less than or equal to negative 12. Okay, I'm going to start by subtracting 2 from each side, and x divided by 4 is greater than or equal to 10. Remember, when I have a denominator that I need to eliminate, I do that by multiplying because the opposite of division is multiplication. So now I have x is greater than or equal to 40. Over here, subtract 2, subtract 2. X over 4 is less than or equal to negative 14. Multiply by 4, multiply by 4, and now I have got negative 14 times 4 is going to be negative 56. Okay, set up a graph. 0. I know that 40 is going to be a little bit closer than negative 56, so I'll put my positive 40 here. I'll put negative 56 a little bit further away. Excuse me. Now here, I'm going to have closed circles because I have greater than or equal to and less than or equal to. So I'm going to have a closed circle at 40. My arrow goes to the right. And then at negative 56, again, closed circle, and my arrow goes to the left. So I see that my answers could be less than or equal to negative 56 or greater than or equal to 40. Any questions on that one? All righty, so that was graphing on the number line, inequalities on a number line. Now we're going to go to worksheet 25. So let me see, I thought I had that, see if it's here. Did I not pull that up yesterday? Yes, not. Let me pull that from my email. I'm already in my sent. Let's see. Is this it? There we go. So I know I've got it somewhere. I just don't know where it is because I've already written on it. I'll just make a new note. All righty. All right, so here we went through our steps and we said, all right, the first thing that I need to do is I need to make a chart using 0, 1, 2, -1, -2 for X and then solve for Y. We plot our points, then we determine, am I going to have a dotted line or a solid line? And then I decide which side to shade on by testing a point. If it makes a true statement, I shade over that point, and that's the side of my line I shade. If it's a false one, then I shade the opposite side of the line. So let's work through this. So the first one, I know that I'm setting up my chart, and we said 0, 1, 2, -1, -2. And I go ahead for the purpose of my chart is I set it exactly, excuse me, as it is, but I put an equal sign. I'm gonna have my X, Y values here. So Y equals -0, obviously that's just gonna be 0, 0. Y equals, I put a negative and then a 1 in parentheses. So if X is 1, Y is -1. Y equals -2. So X is 2, Y is -2. Y equals a -1. So if X is -1, Y is +1. And Y equals a -2. So if X is -2, Y is +2. So here are my ordered pairs that I need to graph. Let's see. All right, so I'm going to start out here and I am going to graph 0, 0, my origin. And then I have 1, -1, so I go right 1, down 1. 2, -2, right 2, down 2. -1, +1, left 1, up 1. And then -2, +2, left 2, up 2. All right, so now I've got my points plotted and I have to decide, is it going to be a solid line or a dotted line? I have a single inequality, so that means I will have a dotted line. So I'm going to dot arrows at the end. Now I've got to decide what side I need to shade on. Now we said that the best possible way is using the origin. Well, my origin is one of my points, so I'm going to have to pick another point. So the point I'm going to check to test is going to be, I'll just use 1, 1. Okay, so remember, I'm going to plug 1, 1 as my test point. So I'm going to plug it in, and I'm going to put 1 is less than -1. That is a false statement. So because this point is not included in making that a true statement, then that means I shade on this side of my graph. Okay, so check yours. Number one, did you set up your T-chart or your graph on your table correctly? Did you get the right ordered pairs? Did you get a dotted line? Did you shade the correct side? Any questions on number one? All right, let's look at number two. Again, first thing I'm going to do is set up my table. X here will be y equals 2x minus 1. And I have my x and y values, 0, 1, 2, -1, -2. So I'm going to plug in and say y is equal to 2 times 0 minus 1. 2 times 0 is 0, minus 1 is -1. So if x is 0, y is -1. Y equals 2 times 1 minus 1. So if x is 1, 2 times 1 is 2, 2 minus 1 is 1. Plug in 2. 2 times 2 minus 1. 2 times 2 is 4. 4 minus 1 is 3. So if x is 2, y is 3. Y equals 2 times -2 minus 1. So if x is -1, 2 times -2, what did I just do? I plugged in the wrong number. Hang on. Should be a -1. All right, 2 times -1 is -2. -2 minus 1 is -3. All right, now I'm going to plug in -2. I was just jumping ahead. 2 times -2 minus 1. 2 times -2 is -4. -4 minus 1 is -5. So if x is -2, y is -5. All right, so we have our points. We're going to plot them. So let me set up my graph real quick. Okay. My first one is 0, -1. So I start at the origin and just go down 1. 1, 1, go right 1, up 1. 2, 3, right 2, up 3. -1, -3, go left 1, down 3. And -2, -5, left 2, down 5. All right, now dotted line, because I have a single inequality, put my arrows on the end. Now 0, 0 is not part of my line, so that's going to be my test point. So I'm going to test 0, 0. So that means I'm going to plug it in up here and put 0 is greater than 2 times 0 minus 1. 0 is greater than 2 times 0 is 0, and 0 minus 1 is -1. In this situation, 0 is greater than -1. So that means since this was true, I shade the side that includes that point. Okay. Questions on that one? All right, last one. Y is less than or equal to 2x minus 3. X, y equals 2x minus 3. X, y. 0, 1, 2, -1, -2. Y equals 2 times 0 minus 3. So if x is 0, y is -3. Y equals 2 times 1 minus 3. If x is 1, y is going to be, so I do 2 times 1 is 2 minus 3 is -1. Y equals 2 times 2 minus 3. If x is 2, and then I do 2 times 2 is 4, 4 minus 3 is 1. Y equals 2 times -1 minus 3. Sorry, guys. 2 times -1 is -2. -2 minus 3 is -5. Y equals 2 times -2 minus 3. 2 times -2 is -4. -4 minus 3 is -7. So if x is -2, y is -7. Set up our graph. All right, plot our points. So the first one will be 0, -3. So I start at 0, go down 1, 2, 3. 1, -1, right 1, down 1. 2, 1, go right 2, up 1. -1, -5, go left 1 and down 1, 2, 3, 4, 5. And then -2, -7 is going to be off my graph. 1, 2, 1, 2, 3, 4, 5, 6. It's going to be about here. I could either estimate or I could leave it off the graph. I've obviously got enough points to connect. Now, looking at my sign, it is greater and is less than or equal to. So I'm going to have a solid line in this situation. Connect with arrows. Now, my origin is not on my line, so that's going to be my test point, 0, 0. So I'm going to plug it in. Have 0 is less than or equal to 2 times 0 minus 3. 0 is less than or equal to 2 times 0 is 0. 0 minus 3 is -3. This is a false statement, so therefore I know that when I shade, I'm going to have to shade on the opposite side of that point. Any questions on that one? Chad?
Can you show me the T-chart for the second problem? I think I accidentally messed up on that.
Sure. For the second one?
Yes, ma'am.
Let's see. We should have 0, -1, 1, 1, 2, 3, -1, -3, and -2, -5. Let me erase some of this so you can, there we go. Now you can see it better. I'll shade.
Thank you.
Any other questions? So the main thing to remember is that with inequalities, I'm going to basically treat it like an equality, except I could have a dotted line instead of a solid line. So that's one thing that's different. And then the other big thing that's different is I have to shade my graph. Because what this means is, since it's an inequality, it means that any of my ordered pairs on either side, whatever side that I've shaded, those are all possible solutions. Remember that when we graphed a line, our line told us all of our possible x, y values that could be a solution to that equation. Same thing here with an inequality, except for there's a whole big chunk of the graph that could potentially be an answer. Okay, so that's why we have to shade to show what those potential answers are. Any questions? All right, we're going to go ahead and shift gears. I know we've only got about 7 minutes till our break, but let's go ahead and shift gears to our packet now that we are using. We're solving systems of equations. Okay. So what I've done here, you will notice, is that our first packet that we've got today, I sent you, I think there's 5 pages. I did number them at the top of the page to help you with that. Thank goodness I had half a brain to think about that. So that way when you print them out and you go, I don't know which page is which. I did put a little number at the top right corner. Okay, so you will see, we're going to kind of scan through these for just a minute, but you will see that I've got lesson 51. On page 1, we go through that information. Then we start on page 3, I think, is lesson 52. But notice that so it appears that I just typed the wrong numbers. So I was going, wait a minute, that should be 53 and 54. Right here where I have lesson 54 and 55, mark that out. That should be 53 and 54. So in this packet so far, we've got 51, 52, and then I have combined the notes for 53 and 54 because one is for addition and one is for subtraction. So I figured it's going to be better for us just to go ahead and learn it together and then practice the same skills. Okay. So in this packet, actually, for what we've got here, is we're going to kind of condense 4 sections together, okay? So let's go ahead and start. Basically, go ahead and turn to lesson 51 in your book. That's going to be on page 113. That's going to be where we start. So go ahead and turn to page,
Are you going to send out this packet?
Pardon?
Are you going to send out this packet to us?
Well, that was the thing I asked in the very beginning was, did everybody get it printed? So I already emailed it to you. And that was why at the beginning I asked if you had had a chance to print this stuff out. Maybe you thought I was talking about the other stuff. But yeah, so since we're getting ready to get a break, you have this packet in your email. So if you have not printed this out, go ahead and print it during the break. Is there anybody that's going to have a problem with that and not be able to print it? Okay, that's why so at the beginning, I'm sorry if I wasn't clear about that. What I was asking if you had had a chance to print was this packet that I had emailed. All right, so we are starting a new unit on solving systems of equations. And it says a system of linear equations is 2 or more equations that all use the same set of blank, usually x and y. So if you look on page 113, at the top of the page, it says a system of linear equations is 2 or more equations that all use the same set of variables. Okay, so your first blank fill in is variables. Okay, so we're talking about 2 linear equations. Remember, linear equation would be like 3x plus 2y equals whatever. It's where I have to graph it as a line because I have x and y. So therefore, it's a graph that has to be done as a line. And so if I continue going on page 113, my second sentence says the solution of a system of equations is the point or points that are common to all lines in the system. So my second point, the solution of a system of equations is the point or points. So that indicates that it could be one solution or it could be more than one solution, point or points that are common to all the lines of the system. So basically what I'm saying is I've got 2 linear equations. And so if I find values of x and y that work for this one and this one, okay, so that's what I'm talking about, is finding an ordered pair that makes this a true equation and makes this a true equation. So now it says underneath that, lines that intersect will have exactly 1 point as a solution. So if I'm talking about a graph where I have lines, where I say I graphed this line and it looks like this, and I graphed this line and it looks like, whoop, go away, that looks like this, then that point of intersection, I only have one of them because it's 2 lines intersecting. So that means I have exactly 1 point as the solution because those lines intersect. They intersect at only one location. Then the next sentence says lines that are parallel will have no points as a solution. Because think about, if I have a parallel line, remember they're equidistant, or they're the same distance either way, so they're never going to intersect. So they never have common points. Whether it's a horizontal or vertical parallel lines, it does not matter. I'm going to have no points. So what that tells me is that there will be no solution. All my talking dries my throat out. We're going to finish this last point and then we'll take a break. Lines that are on top of each other. So basically, if I have a line right here, if I'm graphing 2 lines and my first one is there and my second one, let me make it better, is exactly on top of it, then you can see that every single point that one line covers, the second line covers too. So in that situation, I have an infinite number of solutions. So we'll have an infinite number of we'll have an infinite number of solutions as the solution. Now, when I have a situation like this, the way I write my answer is all real numbers. So all real numbers are my solution when I have lines that lay on top of each other. Okay, so I'm talking about graphing two lines. If they intersect, there's only one solution. If they're parallel, no solution. So that's how I would write my answer. I'll go ahead and put that as no solution. And then if it's an infinite number of solution, my answer would be all real numbers. All right, we're going to go ahead and take our break. If you need to print this packet, look in your email. It would be the one that I sent last night with the link for today. They were in the same email, I think, I hope. So anyway, if you need any help during the break, let me know, but go ahead and take a break. All righty, we'll get ready to come back. All right, so real quick, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go ahead real quick, turn your screens on just so I can see faces and nods. Make sure everybody's back. Zoe, Sadie, and Micah, are y'all back? Go ahead and turn your screens on so I can see faces real quick. Sadie, are you there? Michael Willoughby? Zoe Owens? Keep your screens on for just a minute so I can get a nod from everybody once everybody gets back on. Okay, so I got Sadie, Zoe Owens, you there? Michael Willoughby? Zoe may still be printing. Micah Willoughby? Has Micah gone to sleep? Micah may be sleeping. Grant, text Micah. Tell Micah to wake up. Zoe Owens. Okay, there's Zoe Owens. Okay, Micah. Micah. All right, so really quick, I want to make sure that everybody does have the sheet that I'm sharing, the solving equations, solving systems of equations. Has everybody been able to print this one out? Okay, awesome. So I just want to make sure that everybody does have it, because I mean, it's going to be one of the things where if we keep on going and you don't have it, I want to make sure that everybody did get it in the email. I don't want anybody to be behind or whatever. Also, sorry, hang on a minute.
Micah's printing the packet off. He said it's taking a while.
Do what?
Micah said he's trying to print the packet, but it's taking a while.
All righty. So here we go, working on our systems of equations. Remember that this is still related to what we have previously talked about. We have been talking about linear equations. We looked at linear inequalities just recently. We looked at how to graph those. Now in this situation, we're not graphing. We will be graphing a little bit later, but for right now, we're not graphing anything, and y'all can turn your screens off if you want to now. I just needed to make sure to see that everybody had what they needed. So we're not necessarily graphing right now, but we are still working with linear equations. So we're going to have some of those same concepts that we've been talking about with a linear equation, where I have an x and y variable, where my solution is an ordered pair. Okay, so when I write my solutions, I'm going to write them as an ordered pair. I'm also talking about when I'm talking about my equations, I still have slope-intercept form of the equation where I can solve for y equals mx plus b. I'm still going to be looking at standard form, ax plus by equals c. Okay, so all of those things are still kind of going into play here. We're doing a different concept, but all of our rules and everything that we've previously learned about any linear equations are still in effect, okay? The same thing with like when we were graphing, and we just a minute ago set up our charts where we put in variables. There's Micah. We just knew you were asleep, Micah. I'm just kidding. All right, you got your packet printed out? Awesome. Good. I just wanted to make sure nobody was behind. All right, you're good. So, we're doing the same situation, and we've learned that if I plug in a value for X, I can solve for Y. So that's what we're going to be kind of looking at here. We're looking at how can I solve two equations at the same time and see if they have common solutions. Okay. So we're going to look at, over this unit, we're going to be looking at three methods of solving equations, solving systems of equations. Okay. So the first one that we're going to be looking at is going to be the substitution method. Okay. So number one is substitution. We're also going to call this one, our book calls this set equal to, or set equations equal. I'll just put set equal to each other. Okay, setting equal and substitution are going to be the same thing. Number two, we are going to be solving systems of equations using the method of elimination. Okay, now when I use elimination, sometimes I have to use addition, subtraction. I may also have to use multiplication and division. So we'll be looking at elimination, dealing with all of our different operations. And then our third method will be graphing. Okay, so those are going to be the three methods that we're looking at: substitution, elimination, and graphing. So obviously we're going to start off with substitution, and this is still in lesson 51 in our textbook. So we're still here. So it says substitution is the easiest method to use. Now, some of these things I may have reworded, or I may have kind of given you a little bit of a clue, because eventually at some point, I'm going to give you systems of equation and you get to pick which method you want to use to solve. So we're going to be looking at how I can use all of these methods to solve for a lot of them. Now, some of them I won't be able to, but we're going to be talking about learning how to look at the two equations and finding the easiest way to solve. So substitution is the easiest method to use when each equation can be solved for Y. Now, realistically, you could solve for either X or Y, but for simplicity's sake, we'll just say for Y this time. So when it says the steps for solving systems of equations using substitution, we're going to go through these steps first, and then we're going to go through an example. Okay, so right now, as we're going through, you may not have a clue what we're talking about, but we're going to get the steps down first, then we'll work through an example. So number one, write both equations in slope, intercept form. Write both equations in slope-intercept form, which means to solve each equation for Y. Because think about slope-intercept. You can come out to the side and write Y equals mx plus b. Remember, that is slope-intercept form. Okay? So our first step is we want to go ahead and write both equations in slope-intercept form. We want to solve for Y. We want to write it as Y equals mx plus b. Now, the second thing I want to do when I'm doing this, you can skip this step, but it could cause you to do a lot more work than you necessarily have to. So by including step 2, it helps me to identify if I'm talking about parallel lines. So look at number 2, step 2. It says, look at the slopes of each equation. Since parallel lines have the same slopes, if you see that both equations have the same slope, you know your answer is going to be no solution. okay? Because if they're parallel lines, I know that they're never going to intersect, okay? So if they're never going to intersect, then you know that they now let me stop and think about this for a minute, because yeah, you know you're going to have no solution. Okay, so and this is kind of midway down the red box on page 113 after the first example where we have like two problems written out. It says find the solution of the systems, and then it says begin by writing both equations in slope-intercept form. That was our number one. Right underneath this, it says at this point, look at the slope in both equations. Parallel lines have equal slopes. If the slopes are equal, all points on the line are the solution. Sorry, I wrote that wrong. Look at the slopes in both equations. Parallel lines have equal slopes. If the slopes are equal, all points on the lines are the solution. Because the slopes are not equal, solve for the common point. Okay, so what I meant to write here is all points. Okay, look at number 3. It says since both equations are set equal to y, I've got me a little typo there. Since both equations are set equal to y, that means that the terms to the right of each equation, so think about when I have y equals mx plus b, I'm talking about this part right here, okay? Since they're both set, when I have y equals mx plus b for both of them, then that means that this mx plus b is equal to this mx plus b. Okay, so it says since both equations are set equal to y, that means the terms to the right of each equation are equal to each other. So you can substitute and set them equal to each other so you can solve for the x variable. Okay, so in that situation, we just said, if I've got each equation set y equals mx plus b, then that means that mx plus b is equal to mx plus b. So then I'd have mx plus b equals mx plus b. So now I can solve for x. Okay, so we're going to look at that. Like I said, right now, probably not going to make any sense, but we're going to work through it. Now it says to use the properties of equality to solve for x. And it says once you have solved for x, plug the value in to one of the original equations, and now we're going to solve for y. So first we solve for x. Once I know what my answer to x is, I plug it in and solve for y. When you have a solution for x and a solution for y, express the solution as an ordered pair. Ordered pair. Remember, that's where we have our parentheses and we have x and y. So when I have solved for both x and y, I'm going to put my answer in as an ordered pair. Okay. So now this example that I have in our notes is the exact same example from the textbook, okay, that's in the red box. So we are starting with 3x plus y plus 2 equals 0 and 2x plus y minus 3 equals 0. So step 1 says I need to solve each equation for y. I'm putting it into y equals mx plus b form. Okay, so I'm going to look at the first one. Remember, I'm solving for y. So the two things that are with y that need to move are negative 3x and 2. to move negative 3x, I'm going to have to add 3x. To move a positive 2, I subtract 2. So whatever I've done on the left-hand side, I have to do on the right-hand side of my equal sign. So I'm going to add 3x and subtract 2. So now for the left-hand side, I have y is equal to 3x minus 2. Any questions on how I got there? My second equation is 2x plus y minus 3 equals 0. Again, I'm trying to solve for y. So I've got 2x with it and a negative 3. I need to move them to the right-hand side. To do that, I subtract 2x and I add 3. But whatever I do on the left, I have to do on the right. So I have to subtract 2x and add 3. So y is equal to negative 2x plus 3. Is everybody good with that? I have now solved both equations for y. I have put it in slope-intercept form, y equals mx plus b. Now remember, step 2 said check my slopes. So my slope of the first one is 3. My slope of the next one is negative 2. I know that these are not parallel lines. They have different slopes, okay? So I can keep on moving. Now, step 2 says to identify the slopes. Step 3 says to substitute and set equations equal to each other. So basically, since I have said that y is equal to 3x minus 2, and I've said that y is equal to negative 2x plus 3, what I'm doing here is I'm going to set these equal to each other. Because if y is equal to 3x minus 2 and y is equal to negative 2x plus 3, then that means that 3x minus 2 is equal to negative 2x plus 3. Does everybody follow that? That if y is equal to this and it's equal to this, then these are equal to each other. So now we are only dealing with a variable of x. Is everybody good so far? So now I can work on step 4, solve for x. So now I have 3x minus 2 is equal to negative 2x plus 3. So now I'm trying to solve for x. So I need to move things. I use my properties of equality to move things from left to right. So I'm going to go ahead and add 2x to each side. And 3x plus 2x is 5x minus 2 is equal to 3. So I'm going to add 2 to each side. So 5x is equal to 5. I'm going to write a little bit smaller so I can fit everything in here. Hang on a sec. Minus 2x minus, oops, sorry, not minus, I'm adding 2x. Plus 2x plus 2x. So I have 5x minus 2 equals 3. Add 2, 5x equals 5. So now I divide by 5. So x is equal to 1. Okay, so we have now solved for x. Is everybody with me so far? So now what I do is I use that value of x to plug it into one of my original equations. Now notice where I get this equation right here, I'm using that one right there. Now I could plug it into either that one or I could plug it into that one. Either way, it does not matter. I just picked one. Or I could even plug it into this one or this one. It does not matter which equation. I've got 4 possibilities I could plug that number 1 into to solve for y, and they're all going to work. Let's look at it. So in this example that I have right here, I would have y equals 3 times 1 minus 2. 3 times 1 is 3, and 3 minus 2 is going to be 1. So now we found that y is equal to 1. Let's go up here and do the same thing. Just for the sake for you to be able to see it, if I have -2 times 1 plus 3, if I'm plugging in that 1 for x, -2 times 1 is -2. -2 plus 3 is 1. So I still found 1 there. Come up here. If I use my original equations before I even put them in slope-intercept form, and I have 2 times 1 plus y minus 3 equals 0. 2 times 1 is 2, so 2 plus y minus 3 equals 0. 2 plus a -3 is going to be -1 plus y equals 0. Add 1, y equals 1. It's more trouble to plug it into the original equations, but you still can. Same thing here. -3 times 1 plus y plus 2 equals 0. -3 times 1 is -3 plus y plus 2 equals 0. -3 plus 2 is -1 plus y equals 0. Again, add 1, and y equals 1. It does not matter which of the 4 equations that I decide to plug my x value into to solve for y, I'm still going to get the same answer, okay? So it's not magic that if you pick this one, you're going to get one answer, and you pick this one, you're going to get another one. No, if you've done it correctly, if you have the correct solution for x, you can plug it into any of those equations and solve for y. So now we found that with this, with these equations, if x is 1, y is 1. So that is our solution written as an ordered pair. We're going to use these same steps to work through the classwork, and I have them right here on your worksheet, so you don't have to shift between book and work and pages. Okay. So let's look. Let's start with the first one. I have x plus y equals 0 and 2x plus y minus 3 equals 0. Step 1, we're doing slope-intercept form. We are solving each of them for y. So the first thing I do here, subtract x.
Wait,
So y equals -x. Question?
what was the the ordered pair for the last problem?
1, 1. We found that x was 1 and y was 1. Okay, so our first in class work, I've solved for y, so y is equal to -x.
Can we say plus 0 as the b?
If you wanted to, you could. You don't have to, but if you want to, we can. It's not going to make a difference though. All right, and come over here and we have 2x plus y minus 3 equals 0. I'm trying to solve for y, so that means I need to subtract 2x and add 3. So over here, I need to subtract 2x and add 3. So now y equals -2x plus 3. So I have set them both equal. Y is equal to mx plus b. So that means the mx plus b of one equation is equal to the mx plus b of the other equation. So what I'll do is I'll go ahead and mark them so you can see we're going to set this equal to this. So I'm going to have -x, and if you want to have -x plus 0, you can. If you just want to have -x, that's fine as well. Equals -2x plus 3. So now we've got to solve for x. We solve for x by combining like terms, by using our properties of equality. So what I'm going to do, y'all know that I like to have my x terms on the left-hand side, so I'm going to start by adding 2x to each side because I want to move my x's to the left. So -x plus 2x is going to give me x. If you want it to be x plus 0, it can be, equals 3. Now again, at this point, if you don't have x plus 0, if you went ahead and just eliminated that, you can see that x is equal to 3. It's not necessary to put the plus 0, but you can if you want to. But if you don't put it, then you just already see that x equals 3. Okay, so now we have found the value of x. We need to plug it in to solve for y. So now what I'm going to do, I just typically like to take the first equation that I have used. And again, I could use the very first one, or I just usually like to set it like this because since I'm solving for y, it already has y equals something. So now I'm going to use that equation, and I'm going to have y equals negative. This is where I have to be super careful. Remember that when I am plugging in a value for x, I have to pay attention to positives and negatives. So I'm going to go ahead and put negative parentheses plus 0, or negative parentheses by itself. So this is where I plug in my 3. So that means that y is equal to negative 3. Okay, so that means if x is positive 3, y is negative 3. So I write my solution as an ordered pair. Now, what I want to do, just for you to be able to see how this works, I'm going to start with my original x plus y equals 0. And 2x plus y minus 3 equals 0. And I'm going to show you what happens when I plug my solutions in. So I said that if x is 3 plus y, which is negative 3, that equals 0. So 3 plus negative 3 is 0, and 0 equals 0. Okay. Over here, 2 times 3 plus negative 3. Whoop, hold up. Let me put that in parentheses. 2 times 3 plus negative 3 minus 3 equals 0. So 2 times 3 is 6, plus a negative becomes minus 3 equals 0. 6 minus 3 is 3, 3 minus 3 is 0, and 0 equals 0. So when I plug in both the values of x and y, I end up with 0 equals 0. Okay, so that's how I know if you want to check your work and you want to make sure you got the right answers, that's how you do it. You just plug in both of the values that you found and make sure it makes a true statement. Okay, let's go ahead and look at the next ones. The second one in classwork, I have 6x minus y plus 6 equals 0 and negative 2x plus y minus 2 equals 0. Step 1, solve them each for y. Y equals mx plus b form. Excuse me. So in this one, I'm trying to solve for y. I know that I need to move this 6x and I need to move this 6, but what I also have to be careful of is that negative right there, okay? So I know that I'm subtracting 6x and 6 from both sides. So now I have negative y is equal to negative 6x minus 6. Remember, I need to solve for a positive y. So to be able to do that, I change my signs of everything because that's the same as multiplying by a negative 1. So that means y is equal to 6x plus 6. Okay? Because I have a negative sign in front of y, I've got to make sure to make it positive. Now the same thing over here. I need to solve for slope-intercept form. So I need to add 2x and add 2. Add 2x, add 2. So y is equal to 2x plus 2. I have them both in y equals mx plus b form. So that means now I can set 6x plus 6 equal to 2x plus 2. Now I'm going to solve for x. Combine my x terms, combine my constants. So I'm going to take 2x away from both sides, and 6x minus 2x is 4x plus 6 equals 2. Now I'm going to move the 6. It's positive, so I move it by subtracting. I subtract 6 from both sides, and 4x is equal to negative 4. To solve for x, I'm going to divide both sides by 4. Divide by 4. So x is equal to negative 1. So now I have found the value of x. I need to plug it in to find y. So like I said, I typically just plug it into my very first equation that I've dealt with. So I have y is equal to 6 times -1 plus 6. So y is equal to -6 plus 6, and -6 plus +6 is equal to 0. So if x is -1, y is 0. So I write that as an ordered pair, -1, 0. Any questions on that? So again, I could go to any of these equations, plug in, x is -1, y is 0, and it's going to make a true statement. Let's look at our last one. -x plus 2y plus 1 equals 0, and 3x minus 2y minus 7 equals 0. Step 1, solve for y, slope-intercept form. So in this one, what do you notice?
There's
And
a
actually,
2 in front of y.
there's a 2 in front of y. So that, what does that mean I'm going to have to do to split y apart?
Divide.
I'm going to have to divide by 2. So that means I'm going to actually end up dealing with fractions. And this was something that I started to say earlier and I skipped it and I should have said it. Go back to our notes for just a minute. Go back up. And where was it that I started to say it, but I didn't? It was right. Well, right here in the very beginning, where I put each equation can be, that it's easiest to use when each equation can be solved for x. Go ahead and add on here, or, I'm sorry, solve for y, put or x, add that to your note. Because actually in this problem, it's going to be easier. No, it's not. I am just still solving for y. So actually in this one, you can either solve for x or y, but let's go ahead and work with this one, because on this one, I know y'all will be so super excited we get to work with fractions. For some reason, this book loves to make it a little more complicated and make us work with fractions, but that's what we're going to have to do here. So we're still going to solve for y. That means we're going to have to deal with fractions. So I'm solving for y. So I'm going to have to add x and subtract 1 from each side. Add x, subtract 1. So 2y is equal to x minus 1. So that means I have to divide by 2, divide by 2, divide by 2. Every term has to be divided by 2. So now that means that y is equal to 1/2 x minus 1/2. Okay, so since we have to divide each term by 2, I'm just going to go ahead and have to leave it as fractions. We're going to do the same thing over here with the next one. I'm going to subtract 3x and add 7. Subtract 3x, add 7. So -2y is equal to -3x plus 7. Now I divide by -2, divide by -2, divide by -2. Excuse me. So now in this situation, -2y divided by -2 is y equals -3 divided by -2. My negatives become positive, so I'm going to have 3/2x. Now positive 7 divided by -2. A positive divided by a negative becomes a negative. Now I have -7/2. Okay, so now I do have y is equal to mx plus b. So those are the things that I'm going to set equal to each other. I'm going to have 1/2 x minus 1/2 equals 3/2 x minus 7/2. So now I have to start thinking back to pre-algebra and before when I worked with adding and subtracting fractions. Okay. So now I could do that. Or what did we learn several chapters ago about when I'm dealing with things with denominators? How can I get rid of those denominators?
Multiplication.
I can multiply. So what I want you to do is when you get to something like this, it's going to be super complicated. I mean, well, I'll say super complicated. We don't typically add and subtract with fractions a whole lot. We typically add and subtract with whole numbers. So a lot of times it's going to be easier to go ahead and eliminate the fractions so it's not as confusing, okay? Working with fractions is not something that everybody is super comfortable with, so it's much easier just to eliminate the denominators and then work with whole numbers. So in this situation, what is the denominator of every single term? It's 2. Good. So I don't have to find a common denominator. I just use the same denominator and it's going to eliminate every single one. So I'm going to just go ahead and multiply everything by 2. So now 2 times 1/2 x is just going to give me x minus 2 times 1/2 is 1 equals 2 times 3/2 x gives me 3x, and 2 times negative 7/2 is negative 7. Now, doesn't that look a whole lot better now that I've got numbers that I can actually work with and I don't have to worry about, oh my goodness, I'm going to have to do common denominators and add and subtract, or I've got an improper fraction. Does it need to be a mixed number? I don't have to deal with any of that. I've eliminated the denominators. All right. So now I can go about dealing with, and I subtract 3x and subtract 3x. X minus 3x will give me negative 2x minus 1 equals negative 7. Add 1, add 1. Negative 2x is equal to negative 6. Divide by negative 2, divide by negative 2. So x is equal to 3. Okay, we thought we were going to be totally stumped by this one. X is negative 3. So now I'm going to use that x is equal to negative 3 to plug into one of my original equations. Now, if in this situation, I'm going to start with one of my original equations. I'm not going to work with one of these with fractions, okay? So that's why I want you to know it's okay to use any of these equations to be able to plug in the value of x. I'd rather not deal with those fractions. So I'm going to actually use just my first original equation, which was negative x plus 2y plus 1 equals 0. Okay? So because x is 3, I have negative 3 in parentheses plus 2y plus 1 equals 0. So negative 3 plus 2y plus 1 equals 0. I'm going to combine my like terms. I've got negative 3. I'll go ahead and I've got negative 3 plus 1. Okay, so negative 3 plus 1 is negative 2 plus 2y equals 0. I'm going to add 2 to each side, and I have 2y is equal to 2. Divide by 2, and y is equal to 1. So now my ordered pair solution, if x is 3, then y is 1. I'm going to follow the same exact steps every single time that I am solving using substitution or setting them equal to each other. The reason I call it substitution is because I am substituting the mx plus b part for y in an equation. So basically, I've just taken the y's out and I'm substituting in the other part of the equation. Questions about what we've just done? Remember, steps in a process. Use these steps, look at these steps as you're going through to practice, okay? So what I want to do right now is your homework will be page 114. Come down here and notice that I've put an assignment right here. And it says on a sheet of notebook paper, complete activities 2 So if you look at page 114 at the top, you have 3 problems in activities 2 that's going to be using solving by substitution. Okay. And then finish activities 3 on page 114. The reason I say finish is because we're getting ready to do the first 2 on the left-hand side, the left-hand column. This is just practice on order of operations and solving. Okay, so activities 3, page 114, we're going to do the top and bottom on the left-hand column as practice. All we're doing is using order of operations. So if you need to think PEMDAS, that's what we're doing here. Okay. So page 114, like I said, I've already got these in your packet, so you don't have to rewrite these. On your homework, though, you will get a brand new sheet of paper. You will solve the 3 problems in activities 2, and then you will complete the 4 additional problems in activities 3 on that same piece of paper. So on that sheet of paper, huh?
Did we number these?
We haven't, but you can, I mean, you can number them however you want to, because they'll have, what I'll do is when I send the answers, I'll make sure to write the original equation so you'll know which answer goes with what problem. Okay. So obviously for activities 2, it'll just be 1, 2, 3 across the top. For activities 3, it'll be a little bit different because you've got 4 problems. All right, so activities 3, page 114, we're going to start here. Now, one of the things about when I have equations and I'm simplifying on both sides, I can simplify on both sides at one time. So on the left-hand side, the first thing I'm going to have to do is distribute my 3. And then on the right-hand side, my first thing I'm going to do is divide. So I'm going to have 3x minus 6 plus 7 equals 5 plus 4 minus x. So all at the same time, I did a step on the left and a step on the right. Now, if there was nothing I could do, then I would just do whatever I could do. All right, so now on the left-hand side, I'm going to combine -6 and +7. And on the right-hand side, 5 plus 4. So I have 3 plus, 3x. 3x plus 1 is equal to 9 minus x. Now, I'm still working on solving for x. Add x to each side. So I have 4x plus 1 equals 9, minus 1, minus 1, 4x equals 8. Divide by 4, so x is equal to 2. Order of operations. So if you look on page 114 across the top, you can see that you're going to have some distributive properties going on with all of those across the top. Okay, you're going to need to distribute before you can deal with order of operations. Think about your steps, but like I said, you can do multiple things at one time when you're working on the left and the right-hand side. Now, if you look across the bottom, I have everything, I have fractions. All 3 of them across the bottom have a denominator. So we're going to do an example of that one. The first thing I want to do is get rid of that denominator. Remember, to get rid of the denominator, I multiply. And my denominator is 3, so I multiply everything by 3. And 3 times 2x divided by 3 leaves me with 2x. So when I've multiplied there, I'm just left with my numerator, and 3 times 1 is 3 equals 3 times -5 is -15. So now I subtract 3, 2x equals -18, divide by 2, x is equal to -9. Okay, so for this homework, your assignment is you're going to complete on a different sheet of paper activities 2, and then finish the 4 problems for activities 3. And that will be all of your homework on this section. Okay. Obviously, we're about out of time. And so we will pick up on Monday with lesson 52. Okay. So for now, you're stopping, and your homework is this assignment right here. Questions? Any questions? Okay. Remember, you do not have to send me anything. You're going to do this assignment on a separate sheet of paper. You don't have to worry about lesson notes because that's my part. I'm going ahead and we're putting our lesson notes in here. That way we are all having the same lesson notes. We're all following along the same thing. That takes a little bit of work off of you to have to do extra notes on your homework. Okay. So on a sheet of paper, you're just going to do this assignment. Now, one thing that you do need to make sure to do is label your assignment. I need to see that this is either lesson 51 activities 2 or just put at least page 114 activities 2. I need to be able to look at your piece of paper and know what page it went with and what activities it is. Okay. So I still need to see all your work. You will be turning this paper in with homework when we return to the co-op. Okay. So all this completed by Monday. I will send answers for you to check it before Monday, and then we'll answer any questions that we need to answer on Monday. Or if you have questions between now and then, let me know and I'll be happy to help you. Okay. Is everybody good? Everybody knows what's expected? All right. I hope everybody has a great weekend. I hope, I know that getting to Thursday is kind of like, especially the first week back after a break, when you finally get to Thursday, you're kind of whipped, or at least I am. I know that the first week back is always kind of difficult. We've been used to kind of hanging out and not having to do a whole lot. And now we're like having to get back to work. So anyway, I hope y'all have a great weekend. I hope you get some rest. Let me know if you need help with anything. And if not, I will see y'all on Monday. Okay. All right. Bye, guys.
Bye. Thank you.
Bye. Thank you.